Okay, we're going to start discussing graphs of logarithmic functions by first just realizing that logarithms are the inverse of exponential. So this is an exponential graph, 2 to the x. 2 to the first is 2, 2 squared is 4, 2 to the third is 8, 2 to the 0 is 1, and so on. Exponential graphs, unless you have shifted them, go through the point 0, 1. The inverse function of y equals 2 to the x is y equals log base 2 of x. Okay, and log base 2 of x is, when I input x, the question I need to answer is, what do I need to raise 2 to get this number? So you can think of it that way. You can also think of it as the reflection of this graph over the line y equals x, because that's how all inverses work. So if I put y equals x in this diagonal line, the point 0, 1 that's on every exponential graph, the point 1, 0 is on every logarithmic graph. That is until we start to shift it. But in general, logs go through 0, 1. Now this one's base 2. So if I input 2, I get log base 2 of 2. That's saying, what power do I need to raise 2 to get 2? And that's the first power. A lot of 2's in there. If I input 4, all right, 4 is a, quote, good value on a log graph of log base 2 because 4 is a power of 2. All right, this little point right here is there because log base 2 of 4 equals 2. All right, log base 2 of 4 means, what power do I need to raise 2 to get an answer of 4? And then log base 2 of 8 is 3 because 2 to the third equals 8. So we're just inversing the process. We're doing the other order. Instead of me saying, what is 2 to the third, and you saying it's 8, I'm saying, what do I need to raise 2 to get 8, and you're giving me the 3. Another feature of log graphs, the x-axis is the horizontal asymptote on an exponential graph. The y-axis is a vertical asymptote on a logarithmic graph. So it's going to come right up against the y-axis, up here, and then it's going to take a sharp turn to the right and go out that way. All right, so the first thing to know about logarithmic graphs is they are the inverse of exponential. Before we get to some more graphs, let's just do some basic log calculations. First of all, if you just see log log with no base written down there, it's assumed to be log base 10. All right, it's kind of like square root. This is the square root of x. There's a little implied 2 right there that I don't see. Same goes with a log base 10. So this first one, log of 10 equals 1, because what do I need to raise 10 to get 10? First power, 10 to the first is 10. So log of 100 would be 2, because 10 squared is 100. Log of 1,000,000 would be 6, because 10 to the 6th equals 1,000,000. All right, so some base 3 logs. Log base 3 of 81, that is saying, what do I need to raise 3 to get 81? And the result is 4, because 3 to the 4th equals 81. All right, just doing the process backwards. 3 to the what equals 1/9. So if your argument of your log function is a fraction, you have to think, how do exponentials turn into fractions, or how do they get to the bottom? 3 squared is 9, but my answer is not 2. My answer is -2, because 3 to the -2 equals 1/9. And then log base 3 of -9. This is saying, what do I need to raise 3 to get -9? Can you think of anything? Hopefully not. 3, this does not exist. There's no such thing as the log base 3 of -9, because you can't log negative numbers. Exponentials never result in negative numbers. and you can never log negative numbers. Remember how the log graph is only on the right. There's nothing you can raise 3 to get negative 9. Okay, so back to the graphs. These graphs are going to shift and stretch and flip just like any of our other graphs. So it's kind of like when we graphed exponentials. You want to have an idea of the transformations that get that graph where it is, but when it's all said and done, you also want to check some x values and make sure that your graph is going through the right spots. So I'm just going to sketch log base 3 of x lightly. Log base 3 of x would go through 1, 0, and 3, 1, and 9, 2, and it would have a vertical asymptote at the y-axis. So this is the graph before I do any translations to it. All right, this is just log base 3 of x. All right, it goes through. My good values are 3 and 9 because those are the powers of 3. Okay, so this graph is this starting red graph, but I have x plus 4, which is a left 4, and a down 2. And so all of my points are going to be translated in that way. My suggestion is that you start by translating your vertical asymptote. All right, if your whole graph has been moved 4 spots to the left, then your vertical asymptote has been moved 4 spots to the left, and we'll be over here at negative 4. Then my point that was here at 1, 0, if it goes 4 left and down 2, 1, 2, 3, 4, 1, 2, it's now right there. This point, 1, 2, 3, 4, 1, 2, and 1, 2, 3, 4, 1, 2, and connect the dots. A little wobbly there, but you get the idea. Okay, so when I'm done, I want to double check and see that my graph went through the right spot. So I see my answer going through 5, 0. I just want to confirm by plugging in 5. Log base 3 of 5 plus 4 minus 2. Well, that's 9. Log base 3 of 9 is what do I need to raise 3 to get 2 to get 9, which is 2. 2 minus 2 is 0. 5, 0. So it worked out. Okay, so that's what I mean by graph it with translations, but at the same time, I'm always looking for those, quote, good points, those good x values that I can sub into the equation, and they're good as in their powers of 3, or they make the parentheses be a power of 3. So the things I'll be checking for are the location of the asymptote, and in this case, these 3 spots should be exactly marked on your graph. Alright, so here's one with a little bit more done to it. The big difference here is that this one is negative 2 log base 2, so that's going to have a vertical flip on it. So let's see, I'm going to start with my asymptote, x plus 1. This is a right 1. So here is my vertical asymptote. Alright, I cannot log anything negative, so my x value needs to be bigger than 1 in order for this function to be defined. So my domain is going to be greater than 1. Now, my original point, my original 1, 0 point on my graph would have been right there. I'm going to actually go ahead and sketch a few points. Log base 2 would go through these red points, 4, 2, 8, 3, a little bit steeper than log base 3. But these 3 red points are part of y equals log base 2 of x. So let's translate these points, and we'll be translating the whole graph as we do that. Alright, so this first, let's list out all the transformations. We've got a right 1, we've got an up 3, we've got a times 2 stretch, and we have a vertical flip. So that vertical flip is going to make our graph go this way instead of this way. But we're just going to kind of do it a point at a time. All right, so let's start with this guy. This was kind of like our go-to point. It was right on the axis. It was right on ground level. Let's move that point. So this point, it's the flip. If it's right on the axis, the flip over the axis and the stretch aren't really going to affect anything. They aren't really going to be seen. So it just needs to be moved up 3 and right 1. So there's where our original point moved to. Okay. This point, it needs to be flipped vertically, stretch times 2. Let's actually stretch it first. So a times 2 stretch gives it twice the height that it originally had. So it was at a height of 1, then it will go to a height of 2, then it will flip vertically down here to -2, then it will go up 3, right 1. 1, 2, 3, 1. Here it is. All right, I know I'm making a lot of spots as I go, but these heavy blue dots are the dots that make my final graph. Okay, so this guy right here that was at 4, 2, we're going to stretch him times 2, which makes him have a height of 4. We're going to flip him down to -4. And then we're going to go up 3 and right 1. 1, 2, 3, 1. Now he's right here. And 8, 3, stretch it up to 6. Flip it down to -6. 1, 2, 3, up, right 1, gets me to right here. Now I should have had an idea what this thing was going to look like before I ever started, but by using these good points and translating my good points, I can kind of create that shape and get an accurate picture at the same time. So this graph is flipped over, it is stretched by 2, and it's been shifted up and right. Okay, and the fail-safe, when you're done, sub in some values. Plug in a 9 and make sure you get -3. Plug in a 2 and make sure you get +3, and so on.